Okay, so here we have another set of data, and we want to compute the standard deviation of our data here. This is actually the number of siblings that we all answered that we had for our class a couple of classes back. So this is actually that data. So number of siblings, we want to find out, first of all, to compute the standard deviation, we need to figure out the mean. So we're going to take each of our data values. So we compute the mean here by just taking each of our data values and totaling them up. And then divided by the total number of values, which in our case was 1, 2, 3, 4, 7. Okay, so we'll just add all those up and then divide by 7. So 2 plus 5 plus 3 plus 6, 5 plus 1 plus 5. 3, 6, 5, 1, 5. Okay, so when we do that, we get a total of 27. And then that's divided by 7. So we do that, and that's probably going to give us a pretty ugly decimal, but we'll round off. We'll just say 3.86. We'll just say 3.86, rounding off to 2 decimal places. Okay, so this time our mean is kind of a little ugly, and that's going to happen sometimes. In fact, a lot of times, unless you get really lucky on some of your problems. Right? And we're just going to make our chart to compute steps 2, 3, and 4. So usually what I do when I'm computing step 2, is I usually take my data values and write them in order. I don't have to, but uh, I find it's just a habit that I do here. So I would have 1, 2, 3. There's no 4. So then I'm going to have 5, 5, 5, 6. Then we're taking each of those values and subtract off 3.86. So 1 minus 3.86 would be a negative 2.86. And then a negative, sorry, it should be actually, 2 minus 3.86 will be a negative 1.86. 3 minus would be, which is just negative 0.86. 5 minus will be 1.24. So I'm actually going to have that 3 times. And 6 minus would be 2.24. Okay, so we just took each data value and we subtracted off the mean. Okay. And then we just take those answers and square them. We're taking each of those values and then subtracting off the mean. Okay, so and then we're going to square them. So negative 2.86 squared is going to be 8.1796. And I want to keep this as accurate as possible. 8.1796. And then we do the same thing. A negative 1.86 or positive, it actually doesn't matter because we're squaring it. 34596. and then 0.86, 0.7396, and then we have the 1.24s, 1.24 squared, 15376, and then another 1.5376, and then another 1.5376, and then finally our 2.24, 5.0176. And then we're going to take each of those data values that we just computed, and we're going to add them all up to get our total. Take each of those data values, we're going to add them all up to get our total. Okay. So go back on my calculator and do that. 8.1796 plus 3.4596 plus 0.7396. And then here I'm just going to do multiplication, 1.5376 times 3. And then plus our last one there, 5.0176. Okay. So we add all those up, you get 22.0092. 22.0092. And now at this point, now that we've added them all up, we're ready to go to step 5, which is to divide by 1 less than the number of things we have. Okay. We had 7 things, so we take that answer and we divide by 1 less than 7, which would be 6. And then take the square root of that answer. So again, like I said, I usually combine steps 5 and 6 together and do them all at once on a calculator. So you'll usually, when you're doing standard deviation, you're not going to be dealing with many more values, probably around this type of amount, 5, 6, 7, 8 values. Yeah, nothing extreme. So then we just compute it. Square root 22.0092 divided by 6. Doing that again in parentheses around that quantity. And we get our answer, 1.915, or rounding off the 2 places, 1.92. 1.92. So the average spread here, as far as number of siblings, is 1.92, meaning that we're pretty spread out. We're pretty spread out, and we can see that as we look at the data. It's pretty spread out. An average of 2 sibling difference for each person between the mean. Okay. All right, so that is the standard deviation.